Hello and welcome. In this tutorial we're going to implement a pixel stretching effect in Max. So this tutorial consists of 3 parts. The first one is setting up the feedback system, so we will work with a texture feedback. The second one is then going over the pixel stretching principles, and building on that, in the third one we will implement the full code. So let's start with setting up the feedback system. I am starting with an almost empty max patch, so I have a jit.world because we're working with textures and this is going to be our rendering context. I have a jit.p window to monitor what we're doing, and I have some input videos here. So starting with the feedback system, I'm going to work with jit.gl.pix codebox. In here, the first inlet will be just a video input. Let's call this pic in for picture in. The second one will be our feedback input. Let's call this fb in. That's going to be in 2. And yeah, I think I can leave it like that for now. Then let's just say that the output is our input picture. I will also create some textures out here. Let's make this one full HD, and let's say depth 0, so nothing changes. So this is the input, which will be one of those videos. Then we have the feedback input, which is coming from the output, and then we can also put the output in here just to see what's going on. So if I'm starting this video and then starting the jit.world, we can see that this is already working. Okay, coming to the second part, the pixel stretching principle. So I think I will make some space here first. So what are we trying to do? We're taking a very narrow slice of the whole picture that's coming in and then stretching this over a predefined area. So what does this mean? Let's first create this narrow slice, or let's just call it edge. And also let's put it out here so we can see what it looks like. And just to illustrate the principle, here I'm going to say, okay, this is true or this is white when our normalized coordinates are, I don't know, let's say they are smaller than 0.05. Let's input this here, so this gets banked so we can see what's happening. So we can see now that everything that's smaller than 0.05 in the normalized coordinates is white. When I'm changing this, the edge of course gets bigger. And what I want to do now is essentially use the input picture. So now you can see that we have a small slice of the input picture. Again, if I'm making this bigger, we have a bigger slice of the input picture. So I want to sample this at an offset. So we're not taking the original position, but we're taking the position that's slightly above it. So we can redefine our feedback input and say, okay, we're sampling this with normalized coordinates plus a small, okay, this is wrong, plus a small offset. So the offset is going to be 0 in the x direction and something very small in the y direction. I don't know, let's say 0.01 for now. And then we want to use the mix operator for our output and say, okay, when this is true, the edge, so when this is 1, we want to use the input that's coming in. And when it is 0, we want to use the feedback that is coming in. So again, when this one is 0, we're getting the feedback that's coming in, and when this one is 1, we're getting the picture that's coming in. And as the feedback that's coming in will be sampled slightly above its original position, the whole thing is going to start moving downwards. Okay, in this case it's moving upwards, we have to use a minus here. Now you can see we're just taking a very small slice and we're shifting it downwards. If I'm stopping this and I'm using a jit.bang, we can just bang this here and we can see that the original picture is not moving, we're just taking the row of pixels that is up here. Again, we can use it with the skyline. Okay, this doesn't look that interesting. This looks interesting. Okay, so what are we doing? We're using an edge to decide if we're taking the feedback input or if we're taking the original picture. The edge is very small, so by doing this offset sampling, we're just taking the edge and stretching it over the whole picture. Yeah, so this would be the pixel stretching principle. But we don't just want to, especially in this video, I mean, this is also a very cool effect, but in this video, I don't want to stretch just the top row across the whole picture, but I want to create a mask that decides where this stretching will be applied and where we don't want to apply it. So, I mean, essentially, I can get rid of this. I will need those. We're now moving on to the third part where we're implementing the whole code. And I will start off by creating this mask that decides, okay, where do we want to stretch and where we don't want to stretch. So again, I'm using a texture. Then I will create a noise with one plane, float 32. Let's say this is 1, 1 for now. I'm going to copy this here so we can see what it looks like. And then I'm going to say dimension $1, $1, and bang in this message. So what this does is it sets the dimension on both axes to the same value. So now we have 6 by 6 and then we're getting a bang so that we can output what's coming out here. So then we can create another input here. Let's call this mask and say this is input 3. And now we can put this in here. We can also output it here so we can see our mask. So what I want to do now is use this mask here to decide whether the input video will be stretched across a given tile. So to do this, first we want to extract the edges. So we have these thin lines that can then be stretched. So to get the edges, I will implement a very crude edge detection. I will start with defining the size of 1 pixels according to the normalized coordinates. So the size of 1 pixel in X or Y direction is 1 divided by the dimension of the input texture. Then to get the edges, I will look for each pixel at the neighbors that are above, below, and to the left and to the right. So we can do something like this. So I'm saying left and then I'm sampling. So I'm using the nearest operator here. The difference between nearest and sample is that the sample operator will interpolate and the nearest operator will just use the nearest value according to the input coordinates we're giving it. So to do this, I will sample the incoming mask at our normalized coordinates plus an offset which has exactly the size of 1 pixel. I will also say that our bound mode equals clamp. So if we're hitting the top or the bottom of the image, it's not wrapping around, it's just taking the last row of pixels we have here. So if we want to look 1 pixel to the left, we have to say that this vector is -1, 0. So this means that we are essentially, so we're multiplying this vector by the size of 1 pixel. So we're looking exactly 1 pixel to the left. Then we can do the same thing for the right neighbor, but in the opposite direction. And up, down is also essentially the same, but on the y-axis. So we can say up is 1 here, and down is -1 here. So for each pixel, we're getting the 4 neighbors. And now to create the edges out of this, we can say something like, let's call just simply edges equals the absolute of left minus right plus the absolute of up minus down. So why I'm taking the absolute, because this could also be negative. And now, I mean, we can just take a quick look at what this looks like. Doesn't look like anything because I think I made a mistake. Variable down is not defined. Oh, I forgot to do this here. Okay, so now we can see all of the edges. But here again, we have all the edges. I just want it for certain tiles. So I will create a parameter and call this one threshold. Let's say that this is 0.5 for now. And then we can apply this here and say, so if this whole thing is bigger than our threshold, I want to output a 1 and else I want to output a 0. So we can see that we have some edges here, but if I will declare a dummy inlet for my parameters, so I can have it all nice and tidy. So this one here, And then I can say, okay, this is the threshold parameter. Plug it in here. And then we can see, okay, if the threshold is 1, we don't have any edges. And then the edges slowly fill in one by one. And if we have 0, all the edges should be visible. Yeah. Okay, now we have the edges, and these edges will then be used to stretch the pixels at these points. So now that we have that, we can create the motion vector. In the previous example, I just hard-coded the direction, so everything was going up or down. But here I want to implement a motion vector that can take any angle. So to create the angle, we can say the parameter angle, and let's say this is 0 for now. Then to get from the angle to the motion vector, I can say the x component of the motion vector is the sine of our angle divided by 180 degrees, because sine and cosine are working in radians, but I want to input the angles in degrees, so I have to do this translation here, times pi, and then the same thing for the y direction, which is then the cosine. So then we can create the motion, let's call the motion vector just move, and this is x and y. But I will also create a parameter called speed, so we can change the speed of movement. Then we can say, okay, this is times 1 pixel and times the speed. And now we can sample the incoming texture at an offset, and the offset will be created according to this movement vector. So to do this, we can redeclare this feedback in and again say nearest. What do we need? Input 2, then we need the normalized coordinates plus this movement vector. And yeah, I will also use a bound mode here. Let's use again clamp so it doesn't wrap around. And to get to the image stretching, we can say that stretch equals, again, the thing we had before, mix of feedback in, then the original picture in, and this will then be done according to our edges. So let's quickly see what this looks like. Now you can see at the corresponding positions, we're stretching the whole thing. If I'm changing this, we can see that the resolution changes, and I can also change the threshold. Yeah, but this is not exactly what I want, because now we're just stretching the whole thing from top to bottom. But I only want this to be stretched according to the mask that is coming in. So to create a stretching mask, we can just say mask equals the mask if it is bigger than the threshold. And let's see what this looks like. Yeah. So we can see that every time a tile is white, we want to have the stretching, and every time a tile is black, we just want to have the original image. And now we can use this mask to, again, mix the stretching image with the original incoming image. So to do this, I can say mix pick in, and then the stretch. And this will be mixed according to the mask. So now I can see certain parts are getting stretched. Okay, what can we do now? We can change the speed at which this is happening. So now it's 1. Let's try something like 4. Now you can see it's going pretty fast. And we could also change the angle at which we want to stretch it. So now the angle is 0. Let's try 90 degrees. So it's going in the X direction. This also looks pretty cool. What we could also do is, instead of manually changing the angle for the whole thing, we could again use our mask and say, okay, we want the angle to change according to what brightness we have in here. So to do this, I will rename this. No, I will just comment it for now and then create the new angle down here. So we can say angle equals the mask that is coming in times 360. So now you can see we're stretching in different direction according to what kind of brightness we have here. So this is already pretty nice. What I also like to do, because now we have all different kinds of angles, I would like to downsample this and say, okay, I want 4 distinct angles. So if I just have 4 angles, this would be 0, 90 degrees, 180, and 270. So then we would only have the vertical and the horizontal axis. I will show you what I mean by that. So we could do something like, instead of angle, we can say the number of angles. Also copy this here, create a float, and then I can say I want to use the floor function of the mask times the number of angles. This shouldn't be 0. Let's say this is 4. So what is happening now is that here we have a number between 0 and 1, and here we have the number 4. So taking the floor values, the output will either be 0, 1, 2, or 3. And then we can divide this again by the number of angles. So the output will be 0, 0.25, 0.5, and 0.75. And if I am multiplying this again by 360, we will get an output of 0 degrees, 90 degrees, 180, and 270 if I have 4 angles here. But I think I made a mistake. Angle is not defined. So you can see now we're only moving on the x-axis and on the y-axis. If I'm saying I only want 2, then we're only moving on the y-axis, either up or down. Yeah, here you can change the threshold. I don't know, let's use another video. And let's say, yeah, number of angles is 2. And you can see, maybe let's use this example. It looks kind of funky if this is moving around. I mean, if the threshold is 1, you can see the original. Then going down with the threshold, moving around, it looks kind of weird with the angles, but if I'm stopping the video, it's just clean moving in one direction. I'm using 4 angles, changing thresholds, using the skyline with 2 angles. Okay, this looks pretty nice. And then of course we can change the dimension here, which also looks pretty cool. So yeah, this was essentially what I wanted to show you. I hope this was useful. Thanks for watching.